In this section, we're going to be solving a few exponential equations. Now, exponential equations are part of the logarithm chapter. So there are actually three flavors of questions that come in your papers. The first is log equations, the second is exponential equations, and the third is modeling equations. Today we're going to do a few exponential equations and how to solve them. I'm going to try and cover a variety of questions that have appeared on the past papers. Right, so the first question is log of 1 plus e to the power of negative 3x is equal to 2. So the first thing we want to do here, and we're solving this. So solve basically means find the value of x that satisfies this equation. So if we had to find the value of x, we have to first somehow get the x out of the log. And as we've seen in past questions, in order to do that, we convert this into an exponential equation. Okay, so the basic method of doing that is if you have log base of a of x is equal to y. If I wanted to convert this into an exponential equation, I keep the base the same, a, y is my power, and this is equal to x. These two equations are the same, just represented in different ways. So over here, it's an ln instead of a log over here. Ln means it's a natural log and its base is e. Now you know by now that e is the Euler constant. So if I had to convert this log equation into an exponential equation, it would be e squared is equal to 1 plus e to the power of minus 3x. Using this method here on the right. So now I have e squared minus 1 is equal to e to the power of minus 3x. I'm trying to isolate the x term. So now that I've isolated the x term, I have to somehow get the x out of the power. So it is stuck here as the power of e. And in order to do that, we log both sides. So I'm going to log both sides. I'm going to be using the natural log because it's e in the equation. So a single log on both sides. So ln of the whole thing, e squared minus 1, is equal to ln of the whole of the right hand side, e to the power of minus 3x. Okay, how does this help us? E to the power minus 3x is a power, and the rule of logs tells us that minus 3x ln e is the same as log of e to the power of minus 3x. So this is equal to log of e squared minus 1. The value of log e is 1, and therefore this becomes minus 3x. Log e equal to 1. You can confirm this on your calculators. And it's something useful for you to remember. E squared minus 1. Now all I have to do is make x the subject. So x is equal to log e squared minus 1 over minus 3. I'm going to leave it like this. This is an exact answer. If they say give your answer to 3 significant figures or 2 decimal places, you can follow those instructions. Right, the next question is 9 to the power of x is equal to 3 to the power of x plus 12. So this is also an exponential equation. So in questions like this where e doesn't seem to be involved, what we can do is whatever exponents we have, we try to write them to the same base. So you can see that over here the base is 3, but here it's 9. So it's possible to make the 9 into a power of 3. so that all the exponents have the same base. So what I'm going to do here, I'll write it as 3 squared to the power of x is equal to 3 to the power of x plus 12. This becomes 3 to the power of 2x minus 3 to the power of x minus 12 is equal to 0. Now, though this looks strange, it's actually a quadratic equation. So you'll notice that 3 to the power of x, if it is squared, becomes 3 to the power of 2x. So in essence, what we're going to do is, let's just say let y equal to 3 to the power of x, in which case the first term becomes y squared. The second term is y minus 12 is equal to 0. And then we can just solve for y. So I am putting these values into my calculator. 1 minus 1 and minus 12. So that gives me y is equal to 4 and y is equal to minus 3. Now y was actually 3 to the power of x, so that means that 3 to the power of x is equal to 4 and 3 to the power of x is equal to negative 3. Now for this term here, there is no value of x that can give me a negative value, and therefore we're going to discard this. Okay. And on this side we have 3 to the power of x is equal to 4. Remember that if there's an x in your exponent and you want to find its value, you have to convert it to a log. So what do we do? You can log both sides, or you can just figure out the log conversion. So this becomes log, the base remains the same, 3 of 4 is equal to x. This is how you convert an exponent into a log. So the power is on one side, and 4 goes inside the log. So this is the value of x. X is equal to log 4 to the base 3. Just going to rewrite that. I'm going to leave it as an exact answer. Here's another type of exponential equation question taken from a past paper. So here what you notice is there are no common bases for the exponents. So here the base is 5 and over here it is 7. So we'll have to go about it in a different way. So what I'm going to do here is try and get the x out of the power. So since the question is solved and I need to find the value of x, right now x is a power. I want to bring it out and not be a power. And so I'm going to convert the whole thing to a log equation. Now in order to do that, generally what we do is just log both sides. So a single log on both sides. I'm going to use log. So log of 5 to the power of 3 minus 2x is equal to log of 4 into 7 to the power of x. Now I can use ln, which is the natural log, or I can use log, and this one's base is presumed to be 10. Either ways it will work. So I'm just going to go ahead and simplify this. So if you have log of 5 with a power 3 minus 2x, that power can be brought out to be a multiplier. So 3 minus 2x, this is one of the rules of logs. And here we have, inside the log, we have two multiplied factors. So you can split them up using the multiplication rule of logs. So I can write it as log of 4 plus log of 7 to the power of x. Now this again can be simplified and the x can be brought out and made a multiplier. And on this side what I'm going to do is I'm going to expand it. So log 5 is going to be multiplied into 3 and separately into minus 2x. So 3 log 5 minus 2x log 5 is equal to log 4 plus x log 7. Okay, so keeping in mind that we are trying to find the value of x, we now have x in two terms. We can gather those two terms on one side of the equation, everything else on the other side, and then try to make x the subject. So we have 3 log 5 minus log 4 is equal to x log 7 plus 2x log 5. Okay, I'm going to do two things now. On the left side, I'm going to combine the two logs. So before I can combine them using the division law, which is if two logs are subtracted from each other, they can be represented as a single log and the two numbers are divided. But before we do that, what we want to do is take the 3 inside. So log the 3 multiplier, if it goes inside the log, it becomes 5 cubed minus log 4 is equal to, and on this side I want to extract the x from here, so I'm going to just factorize, take x out as a common factor, and I'm left with log of 7 plus 2 log 5. Okay. If I wanted to simplify log of 7 plus 2 log 5, I can use the multiplication rule, but before that I want to take the 2 inside the log. So x log 7 plus log 5 squared. And on this side I can now use the division rule, a single log 5 cubed by 4. On the right side I'm going to combine the logs to make log of 7 by 5 squared using the multiplication rule. And finally I'm left with x. X is going to be log, I'm just simplifying 5 cubed, which is 125 by 4, divided by this log, which is log of 7 by 25. That's my x value in an exact form. Right, so here's another type of exponential equation that has appeared on a past paper. It says 2 to the power of x plus e to the power of minus x divided by e to the power of x minus e to the power of minus x is equal to 4. Solve and give your answer to 2 decimal places. Okay, so I'm just going to simplify it using some algebra. So 2 e to the power of x plus e to the power of minus x. The entire denominator I can take over to the other side as e to the power of x minus e to the power of minus x into 4. So I'm going to expand that. So 4 e to the power of x minus 4 e to the power of minus x is equal to 2 e to the power of x plus e to the power of minus x. Now what I'd like to do is some terms are e to the power of x and some are e to the power of minus x. So we can possibly combine like terms. So I'm going to take all of them over to the right hand side. So I get 0 is equal to 4 e to the power of x minus 2 e to the power of x minus 4 e to the power of minus x minus e to the power of minus x. So combining like terms, 2 e to the power of x minus 5 e to the power of minus x. Right, now what to do? One of them is e to the power of x and the other one is e to the power of minus x. One way of solving this is to take the negative term to the other side. So 5 e to the power of minus x is equal to 2 e to the power of x. Now I'm going to try and express the power of e as a positive power. Right now it's negative x, right? I want to try and make it positive x. So how do you do that? you make it a reciprocal. So if you take e to the power of minus x to the denominator, it becomes e to the power of x is equal to 2 e to the power of x. If I cross multiply now, I get 5 is equal to 2 e to the power of x into e to the power of x, which is 2 times e to the power of 2x. So what I have here is 5 is equal to 2 e to the power of 2x. Remember, we are solving. We need the power of x. So we're going to try and isolate the x term. So I'm going to write that as 5 by 2 is equal to e to the power of 2x. Now x is a power. When you want to remove it from the power and find its value, we convert it to a log equation. How do we do that? We log both sides. We log both sides, or you can just convert an exponent into a log using the rules of logs. I'm going to try and do both, try different different ways of doing it in different questions, just so that we all get the hang of it. So I'm going to log, I won't use a log, I'm going to use a natural log because e is already there in the question. So log 5 by 2, ln 5 by 2, here the base is assumed to be e, is equal to ln e to the power of 2x. Now the right hand side can be 2 to the power of x log e, and the value of log e is 1. So that is 2 to the power of x is log of 5 by 2. And we finally get x is equal to log of 5 by 2 divided by 2. Now, since they've asked for the answer in, what was it? 2 decimal places, I'm going to put it into my calculator. And let's see. So that is log of 5 by 2 divided by 2. I get 0.4581 to 2 decimal places. That would be 0.46. Question 5 says 4 to the power of x plus 4 squared is equal to 4 to the power of x plus 2. We did something similar in an earlier question with 3 to the power of x, and that equation we discovered was a quadratic equation in disguise. So in this one, the temptation is to think of it as a quadratic, but if you look at the right hand side, you can write it as, using the rules of exponents, you can write it as 4 to the power of x into 4 squared. So that gives me 4 squared is 16. So 16 into 4 to the power of x is 4 to the power of x plus 4 squared. So we just have 4 to the power of x. We don't have 4 to the power of 2x. It's not going to be a quadratic. We're just going to gather the like terms, which is the terms that have 4 to the power of x. So 4 squared is equal to 16 times 4 to the power of x minus 4 to the power of x. Since I'm trying to solve for x, what I can do is factorize to take the term with x in it out, and I'll get 16 minus 1. So that is 4 to the power of x into 15 is equal to 4 squared, which is 16. So that gives me 4 to the power of x is equal to 16 by 15. Now once again, x is in the power is the power, and I need to find its value. So I convert it to a log equation. I'm going to do it by the other method, which is just use the property, which is if you have an exponent of base 4 power x equal to 16 by 5, if I converted it into a log, it would be log with the same base, which is 4, 16 by 5 goes inside, 16 by 15 goes inside the log, and the power is on the other side of the equation. So this is my solution. X is equal to log of 16 by 15 to the base 4. Question 6 is different because it's an inequality, it's an exponential inequality. The instructions are find the set of values. So remember, with inequalities, the solution also will be an inequality. So it will be a set of values rather than a single value of x. And they would like it in exact form, the solution. Right, so the method is similar. Just keep in mind that there's a inequality. So here we notice that the bases are different for the exponents. So the simplest way to tackle this is just log both sides. So I'm going to use ln here. Actually, it doesn't matter what you use. You can use ln both sides or you can use log. I'm just going to, I usually just as a rule, I use ln. Though you could use both in some cases. So a single log, so ln of the whole thing, 2 into 3 to the power of 1 minus 2x is less than ln of 5 to the power of x. Now keeping in mind that we want to get the x out of the log, so that's always our aim, to remove the x from the log or remove it from an exponent. So in this case, they're both inside logs. We'd like to remove it. The first step on the left hand side is to split this up using the multiplication rule, which says that if there's a single log with multiplied terms, you can split them up into two added logs. So log 2 plus log 3 to the power of 1 minus 2x less than, on the right hand side, we can take x out as a multiplier. So x log 5. Right, now what do we do with the 1 minus 2x? We bring it out as a multiplier. Log 2 plus 1 minus 2x log 3 less than x log 5. Now my aim here is to isolate the x's so that I can make them the subject and solve. So I'm going to expand this, open the brackets. Log 2 plus 1 into log 3 is just log 3, and minus 2x into log 3 is minus 2x log 3 less than x log 5. So there are two terms with x in it. I'm going to combine them on one side of the equation, and these two I'm going to combine into a single log using the multiplication rule. So log 2 into 3 is less than x log 5 plus 2x log 3. I'm trying to solve for x, so I want to isolate the x. I do that by factorizing. Take x out as the common factor. Log 5 plus 2 log 3 is less than log 6. Log 5 and 2 log 3 can be combined after simplifying 2 log 3 and making it log 5 plus log 3 square. Remember, they can be combined only after you take the 2 inside the log. So I have x. These are added logs, so I can write it as a single multiplied log. 5 into 3 squared. And on this side, we still have log 6. And finally, x is log 6 by log 5 into 3 square, 5 nines are 45. And I'm leaving it this way because they've asked for exact solutions. So x is greater than log 6 by log 45. This question is from a more recent past paper, 2024 May June, question paper number 33. It says solve the equation 8 to the power of 3 minus 6x is equal to 4 into 5 to the power of minus 2x. Give your answer correct to 3 decimal places. So here we note that the base of the exponential equations are different. This one is 8 and that is 5. So the simplest way to solve this is convert it to a log. I'm going to use a natural log both sides. So a single log on each side. So log of 8 to the power of 3 minus 6x is equal to 4 times, is equal to log of 4 times 5 to the power of negative 2x. Once you've used a single log on both sides, then you want to simplify the logs using the rules of logs. So 3 minus 6x can be made the multiplier here. 3 minus 6x log 8 is equal to, this can be split up into two separate logs, log 4 plus log 5 to the power of minus 2x. This minus 2x can be brought out as a multiplier. So log 4 plus, log 4 minus 2x log 5. And on the left side, I'm going to just expand the brackets. So 3 log 8 minus 6x log 8. So we're going to combine the x terms. I'll take the 6x log 8 to the other side and bring the log 4 to this side. So we have 3 log 8 minus log 4 is equal to 6x log 8 minus 2x log 5. Now on each side, on the left side, we are definitely combining the logs, but you have to remember you have to take the 3 inside as a power. So log 8 cubed minus log 4 equals, and on the right side, we're trying to isolate the x, so factorize, take x out common, 6 log 8 minus 2 log 5. We combine this using the division law. So log 8 cubed by 4 is equal to x times. We want to combine these, but 6 has to be taken inside the log, and so does the 2. So log 8 to the power 6 minus log 5 to the power 2. And finally, we have x is equal, before we do that, x into, combining the two subtracted logs, we get log of 8 to the power of 6 by 5 squared in a single log. And on the left side, we already have log 8 cubed by 4. And therefore, x is log 8 cubed by 4 divided by log 8 to the power of 6 by 5 squared. The question asks that we give this answer to 3 decimal places. Is it 3 decimal places? Let me just check that. 3 decimal places. So I'm going to put log 8 cubed by 4 divided by log 8 to the power of 6 by 5 squared into my calculator, and I end up with 0.5241. And so to 3 decimal places, that would be 0.524. This next question is taken from the 2023 October-November series, paper number 33. You'll notice that it is slightly different in that it's an exponential equation, but it also has an inequality sign and a modulus. So I'm just going to rewrite that. Modulus of 2x plus 1 minus 2 The whole is less than 0.5. Now, recalling what we did in the modulus chapter, if you want to remove the modulus sign, you square both sides. Both sides. Right, so 2 to the power of x plus 1 minus 2, the whole squared, is less than 0.5 squared. So if I expand 2 to the power of x plus 1 minus 2 the whole square, I get 2 to the power of x plus 1 the whole squared plus 2 squared minus 4 into 2 to the power of x plus 1. That is less than 0.5 squared is 1 by 4. So I'm just going to neaten this up. So I get 2 to the power of 2x plus 2 plus 4 minus 4 into 2 to the power, I'm splitting this up into 2 to the power of x into 2 to the power of 1 less than 1 by 4. These are using the rules of exponents. And similarly here 2 to the power of 2x plus 2 I can write as 2 to the power of 2x into 2 squared plus 4 minus 4 multiplied by 4 multiplied by 2 gives us 8 times 2 to the power of x less than 1 by 4. This becomes 4 times 2 to the power of 2x, and then I'm writing this term minus 8 times 2 to the power of x plus 4, and I'm bringing the 1 by 4 to the left side. So minus 1 by 4 less than 0. And this simplifies to 4 times 2 to the power of 2x minus 8 times 2 to the power of x. 4 minus 1 by 4 is plus 3.75 less than 0. This is actually a quadratic equation. So if I take y is equal to 2 to the power of x, I get 4 times y squared minus 8 times y plus 3.75 less than equal to 0. Now, a quadratic inequality like this can be put into the quadratic function of your calculator, and you will end up with y lies between 3 by 4 and 5 by 4. So 3 by 4 on the left and 5 by 4. Okay, this is the answer part way, because we have to substitute 2 to the power of x back in the place of y. So I'm going to split this up into 2. 3 by 4 is less than 2 to the power of x, and 2 to the power of x is less than 5 by 4. Now we'll know, the question asks us to find the value of x, and x is in the power, so we're going to log both sides to convert it, to bring the x out. So we get log of 3 by 4, I'm using a natural log, is less than log of 2 to the power of x, which can be written as x log 2, and on this side we have log of 3 by 4. So we have x greater than log of 3 by 4 by log 2, and for this one here, if we log both sides, we get log of 2 to the power of x less than log of 5 by 4. That becomes x log 2 less than log 5 by 4, and we get the value of x as x less than log of 5 by 4 by log 2. I'm just checking what the answer is supposed to look like. Give your answer to 3 significant figures. X greater than log 3 by 4 divided by log 2. can be written as x greater than, after I put those values into the calculator, I get negative 0.415. X less than log 5 by 4 by log 2 becomes x less than 0.321. Just checking again. So that is answer to 3 significant figures. I think that's fine. You can just present this as the answer.